Hey, okay, so it's finally time to go hard on streams, which was the whole purpose of learning all that Lambda stuff. Alright, so usually when we use streams to do some sort of processing, it goes in 3 steps. So you can see here at the top of this picture that I stole from someone else, initially you're going to make the data into a stream. Then you might do some intermediate operations like filtering or mapping. A map is when you transform something to something else. And then you're going to do a terminal operation. So a really common one is collect, and that will return a thing that's not a stream. Like a lot of the time it's a list, and there's other versions of, there's other kinds of terminal operations too. Okay, so I'm just going to do a real quick example of that stuff. So let's create a stream. Well, one thing that's used quite commonly is this thing called int stream, and it will give you a bunch of ints. And usually you say you get your ints between, here and here. Okay, so at this point I've created a stream. The next thing I want to do is I'm going to add some intermediate operations. So let's do some filtering. And this is where your lambdas go. So I would say whatever is in there, like it could be an X. Let's just keep the ones that are under 20. Okay, that's the filter, and then we would do something to terminate all of that. So for this, I'm just going to do like some. Okay, and those are my 3 steps. So I don't really care about what this actually does, but maybe we'll print it out for you. I'm just going to refactor this and show you what comes back from it. An int. Okay, so sum returns an int. And then we could, if we wanted to, print out sum. I don't know what that's going to be. It's just some jazz. I really just want to show you guys the steps. So just to refresh again, the first thing you do is you create a stream. The next thing you do is you apply some intermediate. You can have 1, 2, you can have as many as you want in there. Those all keep the stream at the same size. I'll talk about that a little more in a second. And then we want to do the terminating operation. And that closes everything down. It's very important. Okay, so creation, this is a thing that we have. A lot of the time we'll use a collection, like say you have a list of stuff. Then for all collections you can just get a stream right there. Stream from everything that's a collection. And that will give you the stream. Oh, don't know what a list is. Yeah, Java future list. Yeah, not initialized, that's fine. Okay, so I just want to show you that this method is on every collection object, and that by those I mean like a list or a hash map and all those other things that inherit from the collection class or interface. Okay, so those are how you get the streams most of the time. Arrays are a little different, so let me see. I wanted to make an array. Super quick, so I'm just going to make this string into a car array. Let's just initialize that. Okay, will that do? Do you want that? Okay, char array. So we've got an array of cars. And then to get a stream of any kind of array, you do arrays dot. And then stream, yeah. Okay, look at all these options. So it pretty much means you can put any longs, ints, any stuff in there, and it will create a stream for you. So I'm just going to finish this out, stream, and then see if I can put my car array in there, and that gives me a stream, or not. Oh, I guess I can't get one of cars, but there's ways to do that. So usually where I would find these things, I'm hoping that I'm going to be able to show you guys where to look for things. I would go and just say stream Java. I would go Java. Oh, I want to make sure you guys can see that. Pull it down a little bit. Java stream from car array. And then you'll probably get someone who's figured it out. So to get a car array, there's somebody doing it. A little more complicated. You have to map to object. Yep. Okay, so that is how you create a stream. And those are the 3 steps. That was what I just kind of want to give you an idea of how it comes in phases. And how you create them for collections with the .stream method. That's the most important one we're going to be using is the most. And then you may sometimes use the arrays.stream. Okay, what else do I want to tell you? Yes, all right, so here are the 3 phases. You've got the stream source. That was what I was showing you about creating a stream. You can do instream.range. These are just some examples, or arrays.stream. Then you have your intermediate operations like map, filter, distinct. That will narrow it down to just the unique items in a collection. Or then you can sort. We've done a bunch of this sorting with the collections method before. That's pretty much the same. You just stick a lambda in there. And then the next phase is the terminal operation, of which there is 1. Now this for each is interesting. I think I'm going to talk about that a little bit. So before, in the old days, let's just make this an array. Why not? Yeah, so our original, when we were way back, we would usually do for loops like this. You'd be declaring specifically an iterator. An iterator is this I. Some people call it the index, but it's the iterator, so that would like be printing out the stuff, which is a null pointer. Why? Because to car array. Oh, it's because of this, because that's null. Okay, I'm getting my 0, 1, 2, 3. What's that? Oh, because I'm printing out I. I would actually have wanted to get the character. Yeah, this was really clunky when we had to do it this way. Like that. Use the I as an index. Okay, so then we got a bit more fancy and we learned about this for each loop. And then what it was doing is it's also pulling out the character for us, so we don't have to index the array like this. And you would just dump it out like that. Okay, but now we have this other thing. So both of these are examples of what we would call an external iterator. Those things up there are external iterators. Okay, now I'm going to do an internal iterator. And this is something that comes with streams. So the way we would do it is we would get a stream. Do we have a stream already? I've got, let's see. I could use these guys. Okay, so we've got this stream. And this is going to mess me up because I'm going to get a null pointer exception. I'm going to make one out of this. I'm going to do arrays. Oh yeah, I didn't like this before. Let's see if I can cast that. Is it going to get all cranky with me? Cast it to an int array, make it an int array. Ah. Stream, and then let's see if we're allowed to do that first. Oh, it's not liking these things. No. Okay, so I'm really just wanting to show you how I would do a for each. So I'm going to use this guy that I just deleted, that guy, the one with the actual list. There. Okay, so this is how you would do an internal iterator. And we'll be doing this lots. So you do stuff, which is stuff, and then you get a stream of it, and then you do a for each like this. And then this is what you put, what you would want in the for loop. So that would usually, a lot of the time it's a printout. So a lot of the time we're going to be doing this. Ooh, what are those things? Okay, so this is going to go through the whole stream and it's going to iterate through it and it's going to print everything out. This is a method reference. I'll be talking about those later, but it's the same as this. But it's a lot more succinct and easy to read and less typing too. Okay, that's a really fast going through it because I'm going to try and tell you more about it by doing actual examples. What did I want to say about this? Oh yeah, so there's the collections API, and that's quite powerful. It's also a way to deal with a whole bunch of data. It's different. There are a few differences between collections and streams. One interesting one is that streams are lazily constructed and collections are eagerly constructed. Now, those are some strange words, but what it means is that if you're a stream, this filtering is not going to get done until sum is called, and that's more efficient. So if you want something to happen fast and you're actually worried about that stuff, you'll pretty much always be using streams because they're made to be super efficient over bunches and bunches of data. That's why they work the way they do. All right, what else did I want to tell you about? Okay, we'll be getting back to this, I think. I'm going to start on the exercises that I'm going to give you so I can talk through them. This is going to be the bulk of the work that you have to do for these 2 lessons because, you know, it just takes a while to get good at these and it's really powerful. So here I've got a whole bunch. Each one of these tests is pretty much a method that you have to write. I will say that I'm going to go through some of these quickly and some might seem a little difficult until you get familiar with them. So try as many as you can and then you can possibly come back because we're going to do more work afterwards. All right, so where I got these from was these are a lot of the unit tests that we used way back when we were learning about algorithms in the first place. But this time we're going to use streams. Okay, so what I'll do is I'm going to comment out everything but the test that I'm working on. That's the first one. And I'm going to use the quick fix to create this algorithms using streams class. And then I'm going to create the method too. If you guys care about this stuff, you could do it yourself, but okay, so this is going to count the good eggs. Count the eggs that are not cracked. Okay, so I pretty much want all of the whole ones. Okay, so if you had your old hat on, you'd probably be thinking, all right, well, I'm going to for each through this list, and then I'm going to check to see what the string says, and then I'm going to make a counter, and I'm going to add them up, but that's not really the stream way. I'll show you kind of more of the stream way. So I'm kind of just working through these as I go, because there's a lot to know about streams and you end up doing a lot of Googling. All right, so let's see. All right, I've got some eggs. I'll print it out just so we can see them. That's going to be the array list. It's complaining because it wants me to return something. It's going to return 0. And since it's a count, it's returning an int. I think that's a little better. Oh, I think it might be, it's not running my tests yet. From there. Okay, so here it's printed out. This is the array list of eggs, just really strings. And here, if I double click on this, it tells me what's gone wrong. So here it's saying that it expected to get 10 and it actually got 0, which is fine because that's what I told it to do, return 0. Okay, so let's think about the first step. We want to create a stream. So I'm going to do eggs, and because this is a list, I can do eggs.stream. And then I want to count the ones that are whole. So what I could also do is, I think possibly we could filter the eggs by just keeping the ones that are equal to, what's that thing? That are equal to whole. Okay, now I'm not finished with this yet. That's my step 1, that's my step 2, and then once I've filtered just the whole ones, I will add my terminator, which is to count them. Okay. Alright, so I'm going to take this, get rid of that, and I'm going to return this part. And it's got a problem with the type. So this count method, so what it's saying is that my method, my actual code is returning a long, but here as the return type I have an int. A long is bigger than an int, so you can't squish a long into an int. So that's why it's giving me that error. And the reason is because this count method returns a long. So I'm just going to change this to a long. I don't think it's going to really bother my test. Let's see. That's all right. Okay, so I'll run it again. Okay, I got a green bar, so that's working. Do I need to explain this a little more for you guys? I guess I'll just put these steps on here. So here we're creating a stream. Here we're doing the, what did that nice diagram call them? Intermediate operations. There's just one this time because it's a pretty basic thing. And then this is the terminating operation. Okay, so the thing about streams is you can't really, a lot of the time you can't really look inside of them while they're streaming. And that's related to what I was saying about the rest of the stuff not being evaluated until the terminating condition happens. So that sort of means that the stream is in a state of superposition until, that's the way I think about it anyway, in a kind of a quantum way, that it's this count that is going to cause the filtering to happen and run up like that. Okay, I think I'm going to do another example. I'm hoping some will be a little more difficult. Yeah, there's a harder one coming so that I can show you how I work through these things. Okay, so this is another one from the old algorithms exercise. Find the height of the tallest person. I'm just going to create the method here and have a look at the test. Okay, so we've got a list of doubles and we need to find the tallest one. Okay, so this is a situation where you actually don't necessarily need a stream. So you probably remember when we were doing the sorting, we had this thing that was collections.sort. When we were learning about lambdas for the first time, I showed you guys this and we did quite a bit of examples. So it's probably going to be the first thing that comes to your mind anyway, is that you can use this sorting function and not get so embroiled in the stream stuff. So here we put the peeps and here I got to put a lambda. So how do I want it to sort? Well, actually, I don't think I even need a lambda because it's going to, oh, I know what I can do. I think I can use that max thing. Okay, so I'm going to go over here and Google collections max. Looking for the largest item in that stream, not in that list. Okay, so we've got this max thing. Look at that, max value is collections.max. Yeah, see, that's gonna probably be the easiest way for me to get this. Find the maximum. Okay, so that's how I would do it. Every time you find one of these, feel free to consider using the collections API instead of doing the stream stuff. Since we're here, I suppose I should see how I would have done it in a streamy way. Sorted dot. So I'm actually going to look at them right now. So I'm going to do a for each. You'll be seeing me do. I do a lot of this because it helps with debugging. So I'm just going to print them all out and see what happens. This method's complaining because I need to return something for my test. Okay, so let's see what this sorting brings about. Okay, so you can see they're in order. Are they in the right order? Who knows? But let's see. So then I would do something, I'd get in a different terminator. So I actually want that last thing. So let's see what's after the dot. So find first, that's the opposite. I could always do it backwards if there's no last. So let's just see what happens here. So because that's a terminating condition, I'm using my regular old CISO to print it out. It's not going to be iterating. Just want to see what the biggest one is. So it's 3.4. That's not the way I wanted it. And I want a reverse sort. Let's see if there's a way to do that. Let's see what Google thinks. Reverse sort stream. So I'm kind of on purpose working through these things fresh without having done them before, because I want to be careful to show you where I'm getting this information from, rather than just pouring it all out there, because you really since this is all new, we'll be doing a lot of Googling to find out how to use streams to do just a ton of stuff to learn about the library. So this is using a comparator. That looks like a nice solution for me. Oh look, comparator.reverse, that's actually the same. So we did make these comparators before. That was what we were doing with the lambdas when we were sorting the job candidates. Okay, so sorted, I just see now because I looked on the internets, sorted can do its default behavior, or then you can also take a comparator in there, and that's what we're going to do. I'm going to paste that, import my comparator, and then see if we get the big one this time. 6.6. Okay, so that would be what we want. My test is still red, and I would just return this. And get me a green bar. Ooh, not quite. Okay, so this is saying that it's returning a different thing. When you do a find first, what it returns is it returns an optional double because it might not have found any. So I think you can just make this to, can I change this to something? To double? No. Okay, so this get, I know because I've done these things before, but so find first is an optional. Optional is a class I guess this is the Java 8 thing. I haven't really played with this thing, but so optional is a class that seems to store a value, and then to get the value you use get. Here are all its methods. So it's just got a safety check on it, so that it will give you a nice exception if it doesn't find it. Okay, so that's how you would get your double back out, and then I'm gonna just inline this again. Didn't really need it to have it all on there. And I think I'll leave that one in as an option. So I definitely prefer this in terms of readability. Why would you want to use a stream? Possibly for efficiency reasons. I haven't talked about it, and I'm not going to, but you can use streams for parallelizing operations, and that's what this parallel stream thing is, that thing there. Okay, I feel like I'm rambling a bit, but I kind of meant for this one little video to be kind of going off the cuff. Alright, I think I'll go and do another one. Now I'm going to do these first three, and then you guys get to do the other fun stuff down there. Yeah, I do remember that I put a hard one in here, which sounds easy actually to do. Add numbers in a string. Add all the numbers in a string. What do I mean by that? Alright, so I'm going to write a test. Is it that? Yeah. Okay, so this is going to be called test adding a string of numbers. Okay, so what I mean by a string of numbers is this. Okay, now I'm not going to know the answer to that for an assert just yet, so I might have to choose an easier one. Assert equals. Okay, so I'm going to leave that guy till later. For now, I'm going to do something that I can do in my head easily. Okay, so let's do this. The answer to that would be 6. And then I'm going to put the method in with all the rest of them. Okay. Add a string of numbers. Well, I've learned my lesson, so I probably want to return a long. Let's get my test compiling and failing. Failure is good. Means you have a harness. Okay, I'm just going to check to make sure it's an assertion error. Yeah, it's expecting a 6, but it's getting 0. Cool. Alright, so this is going to be fun. I've got to get, I must not have passed my numbers in there. I've got to figure out how to add these guys. Okay, so I'm just going to think out loud a little bit. So we have all the numbers and we want to break them up. So the way it's going to be is like we want to add 3 and 8 and 4, etc. So each number is basically just one character. So that makes me think that maybe it would be a character array, and then you would just have an array of stuff and then you would add them up. It seems like a reasonable thing to do. Well, there's also this thing. So if I just, start doing it like this, I've got this cars thing that's actually going to directly make a stream for me. So let's just do that. Okay, so now that I have the characters, I want to add, I want to collect, let me think. So for each character sum. Is it as simple as that? Can I do that? Huh. All right, well, might as well give it a whirl. No. All right, what happened? Whee. All right, so I got 150. All right, so now I'm kind of, I feel a little blind because I want to really look at the stuff that's in there. So this is where I'm gonna sort of peek in there. So first of all, I'm going to extract a local variable for those things. I'm actually going to extract the whole lot because I just want to return that. And then these guys go together for me. That is the way I feel about it anyway. Just do it like that. Okay, that should be like that. Just make sure that I haven't screwed it up. That was not my finest moment just now. Okay, so I am going to look and see what might be wrong. Okay, so we got the numbers, we got the cars, we got the sum. Sometimes this is nice the way, if you format it like this, you can move stuff out easily. Like I can easily comment that out. And what I'm going to do is put a for each on here. It's my favorite thing to do, is put for eaches everywhere. I use it to debug. So now I can at least look at these cars. Oh dear, we're back to this. Okay, that'll do. Okay, let's run it and see what we're getting. Yeah, all right, so are you guys getting this, the significance? So, you know, the numbers that I have put in here are 1, 2, and 3, and I'm getting 49, 50, and 51, and I reckon if you look at an ASCII table, you would see that those numbers, that's the ASCII value I'm getting, because it's a car or a char. Where are the numbers? Numbers there. All right, so I've got a 1, 2, and a 3. Yeah, look at that. Those are 31. What am I getting back? 49, 50, and 51. Yeah, okay, so I'm getting the ASCII values. So it looks like these are getting treated as ints, not as strings. So somehow I want to make that into a string. Okay, so let's look into how we might convert from this car to a string. Use my buddy Google. Java car to string. All right, that looks okay. Tutorial point. Let's see what you got. Okay, so here we have car C, passed in, string, value off. All right, I'm gonna take that and I'm gonna see if I can use that. All right, so usually when you're converting from something to another thing, you use map. So let's use map. Put that there. And I'm gonna do a dot map as the next operation. And do you know of map? Yes. Okay, map, mapper. All right, so I'm thinking that we have a character and we want to change it into a string. Okay, that's not liking that too much. Type mismatch, cannot convert from string to int. Okay, so this is definitely returning a string, and I would imagine if we look at this map, yeah, see, it's taking an int unary operator. That probably means that it can't have strings. So yeah, there's these map things. See, there's ones for to double, to long, and then to object. All right, I'm gonna try this because string is an object. I think you guys know, but string, because it has a capital S, is an object, and then car with a little c is a primitive type. Everything with a small letter is a primitive type. Everything with capital letter is an object. Object, object, object. Primitives aren't as used as much, I guess, as streams are all very objecty. Anyway, sorry, tangent. Looks like we're going to be able to convert to a string using this map to object. I'm going to get my little for each and I'm going to stick it down here to test that out. See what we're going to get. Okay, no change. We're still getting those values. But I did see another thing down here. Let's see. So that's to convert using value of. And then there's this one using character.toString. Okay, I'm going to try doing that instead. Fingers crossed. Hey, okay, that's better. Okay, so now I've got the numbers. And so we can get back to trying to add these guys up with sum. Okay, not too crazy about that, are you, buddy? All right, so this sum says it's undefined for type stream string. Actually, that's not that crazy because what we have here now, so after this part, we had a stream of characters. After this part, we had a stream of strings, and it doesn't know how to sum these guys. So somehow we need to convert it to an int, which is going to be able to add up. So, int. How are we going to do that? Well, the easiest first thing I'm going to do is see if there's anything obvious that's going to let me convert to an int around here. Map to int. Okay, that's looking good. Map to int. And then I need a mapper. Well, I don't really know what the mapper is. So there's this thing that when you don't want to do an actual operation, you just want to pass in a value, you don't want to make a lambda, you do stuff like this. You just go I goes to I. And then that's for when you don't have a lambda, you just want it to stay the same. But that's not going to be good here, is it? Map to int. Okay, it wants a toInt function. All right, let's see. Map to int. Let's see if it's under map. Do we have map to int in here? No. Map to int with examples. Okay, where is our friend? Map to int. Okay, so here we have map to int, and then, oh, so that's actually telling you exactly how to do the mapping. So I don't know what real use that guy is, but let's jam that in there. I was using I because just to show that it wasn't a character anymore, like C, but num works for me too. And that is compiling, so that's groovy. And now I'm gonna bring my for each down to see what we're getting. I'm hoping to get, yeah, just all numbers, but hopefully they're ints now. And we'll be able to tell by trying to sum them. Can we sum them? Oh, yes. Okay, we're able to sum those guys, so I'm going to just see if I'm going to return that and see if my test will pass. Okay, passing test. Now, there was a lot of stuff going on in there. This was a particularly hard one. I think most of the ones that I have here for you guys to do are more basic than that. But so if you've learned anything from this video, I think it's that Google is your friend. I reckon if you do all of these, then you become a good bit more fluent and then you don't need to use Google as much. But for the meantime, that's the way to go. Just to summarize what's going on here is we're making the stream here by using the .cars method, and then we're doing two intermediate operations. The first one is to convert the car to a string, and then the next one is back to an int. And the reason we had to do that was because the character by default was adopting its ASCII value, and that wasn't giving us the right answer. So then we had to make it into a string, and then we had to put it back to an int so that it could be added up. I think I'm going to let you guys add it. I'm just going to part